Hello everybody, this video will explain the questions in the diagnostic test. Now you will notice that in diagnostic test we have a mix of different types of questions which we have covered in other videos. So we have got 10 questions in diagnostic test. So let's get started with question number one. The question number one says that the level of iron impurities in water sample is 2 milligrams per liter, and we have to express this concentration in terms of ppm. So if you recall from the other videos, I think the conversions, we looked at the different types of concentrations, how they are expressed, and then we also practiced converting from one concentration into the other. So this is the same type of a concentration. So this is the same type of a question where we have been given the concentration in milligrams per liter, and we have to express that in parts per million. So let's get started from the end, because that will give us an idea that what is it exactly we want. So parts per million, if you recall, parts per million is what I said that it's a smaller unit present in the bigger unit. We said it's 1 milligram in 1 liter. 1 parts per million is number of milligrams. So parts per million is 1 milligrams or 1 milliliter present in 1 liter, or 1 milligram or 1 milliliter present in 1 kg. So the smallest unit present in the bigger unit, that's how we remember it. So the second one is not applicable here, but this one is applicable because we are dealing with milligrams per liter. So parts per million, we have to find out how many milligrams actually, how many milligrams. Parts per million is how many milligrams are present in 1 liter, or how many milligrams are present in 1 kg. So we have to find out how many milligrams are present in 1 liter. That will be the ppm. Now if you look at the concentration which is given carefully, it's already given as milligrams per liter. So we know that 2 milligrams is present in 1 liter, and parts per million is the number of milligrams present in liter. So actually 2 milligram per liter is the same as 2 ppm. So that's the answer. Moving on to question number 2. The hospital has 1 liter pre-mixed bag of this is dextrose 5% and normal saline together. So sometimes in some infusions we have dextrose 5% and normal saline together, plus 20 milli equivalent of KCl. The patient's fluid has been running at the rate of 80 mils per hour for 8 hours. Now that's the infusion rate given and the time for how long that infusion has been running, and we have to work out the millimoles. Now one thing to note here is that the concentration of the solution is given in milli equivalent, whereas we have to find out millimoles. Now if you recall from one of the other videos that for KCl and some other compounds where the valency is 1, for these compounds which have valency of 1, for milli equivalent is the same as millimole, right? Now which commonly used compounds have got the valency 1? There is another file I have uploaded which gives you an information about which commonly used compounds have got valency 1 and 2. So KCl is one of those compounds which have valency 1, and for these compounds milli equivalent is the same as millimole. So let's do this calculation bearing in mind milli equivalent, and then that will be the same in the end as the millimole. So we have a solution, a 1 liter solution. So 1 liter solution, and it has 20 milli equivalents of KCl. Now this patient has been receiving this infusion, 1 liter of which contain, don't worry about this one. So the patient has been receiving this fluid 1 liter as which has 20 milli equivalent of KCl at the rate of 80 mils per hour for 8 hours. for 8 hours, and we have to find out how many milliequivalents have gone into the patient at this rate for over 8 hours. So let's calculate how much fluid the patient has received first, and then from that we can calculate how much milliequivalent the patient has received. So if the patient received 80 mils per hour for 8 hours, in 8 hours the patient has received 640 mils. Okay, so now we know that how much fluid or infusion the patient has received. We can find out how much milliequivalent it was present in 640, and that would be the milliequivalent the patient has received. So 20 milliequivalent was present in 1 liter. Now 1 liter had 20 milliequivalents, but the patient has received only 640 mils per so far. So 640 mils will have, so it's this divided by this. Remember, it's milliliter here, so I would convert this 1 liter into 1000 mils as well. So that will be 20 divided by 1000 milliliters multiplied by 640 milliliters. That will be equal to 12.8 milliequivalents, or 12.8 millimoles. Sometimes in the questions, in the options, you might also have an option of 13. So just round it up to 13 because that's easier to deal with. So just a quick recap, we had been given the concentration, that how much milliequivalent was present in 1 liter, and we had to figure out first how much infusion the patient has received. We calculated that how much fluid the patient had received, and then we worked out how much milliequivalents were present in that fluid which the patient had received. So moving on to question number 3. It's a very easy question. What volume of 2.5% stock solution is required to prepare 2500 milliliter of 1 in 500 solution? So if you pay attention to the wording of this question, you will notice that we are required to prepare a solution for this, and the solution which we are required to prepare, we have been given the volume of that, and we have been given the concentration of that, and the starting solution from which we have to prepare, the concentration of that is given as well. So if simply we can apply C1V1 and C2V2 equation. But the problem here is that the concentration present on the both sides is in a different form. So let's convert the concentration on the both sides in the same form. So make sure that the concentration is the same on both sides. It would be easier to deal with percentage. So I will convert 1 in 500 into percentage as well. So the concentration on both sides of the equation will be in percentage. So let's see what is 1 in 500 in the form of percentage. So now in these types of concentration, you remember that I said before that it's like percentage. So basically 1 in 500 is equal to 1 gram in 500 mils. I'm converting that into percentage. So percentage is out of 100. So if 1 gram is present in 100 mil, I have to figure out how many grams will be present in 100 mils. So remember, so the thing which I have to find out, I put it on the right side. So 500 mil has 1 grams. 100 mils will have 1 divided by 100 times 500. And that's 0.2 grams. So 0.2 grams is present in 100 mils, so that means the concentration is 0.2%. So 1 in 500 is equal to 0.2%. So I will plug this in the equation and everything will become clear. So that's equal to 200 milliliters, and that's the answer. So question number 4, a patient with atrial fibrillation needs to be given amiodarone at the rate of 1 milligram per minute for 6 hours. So we have been given an infusion rate and the time of the infusion for the loading dose. You are asked to advise on what volume of amiodarone injection should be added to 500 ml of dextrose 5% to provide the required amiodarone dose. The amiodarone is to be administered by IV infusion. Now, first of all, there are quite a few things going on in this question. One thing is that we have been given the solution or the infusion solution in which the amiodarone would be present, and it's that solution, 500 mils of 5% dextrose. So this is just the solution. Don't consider it as numbers to be included in the calculation. So that, in other words, I'm saying just ignore this. Okay, so just consider it as a solution. Now the dose we have to give to the patient is 1 milligram per minute. Now don't get confused because the infusion rate is given. This is not a conversion of infusion rate from one form into the other. This is just the infusion rate is given and the infusion time is given. So we have to find out how much dose we need to add to the bag. So we have to give to the patient 1 milligram per minute for 6 hours, right? So let's calculate how much total dose we have to give to the patient for 6 hours. So 1 milligram per minute in 6 hours. How many minutes do we have? 60 minutes in 1 hour. So that means 60 times 6 is equal to 360 minutes. So I have to give the dose over 360 minutes, and the dose which I have to give is 1 milligram every minute. So if I have to give 1 milligram in every minute, in 360 minutes I will have to give 360 milligrams. Now the next question is that how do I add this 360 milligram of dose to the infusion bag which I am preparing for this patient? So this 360 milligram of amiodarone will be added to this infusion bag which I'm preparing for this patient. As I said, the question is, how do I add these 360 milligram to this infusion bag? I calculate this from the amiodarone injection. So strength of the amiodarone injection is given, which is 150 milligram per 3 mils. So how many mils of this injection I will add to this infusion bag, which will provide 360 milligram of the dose. So let's take this concentration. 150 milligram is present in 3 mils, but I have to give to the patient 360 milligrams. So that will be 3 divided by 150 times 360, 7.2 mils. So that means I will take 7.2 mils of this amiodarone injection and will add to the infusion bag, which will provide 360 milligram dose to the patient over 6 hours. Let's have a look at question number 5. Here we have got a child weighing 10 kg and he has been diagnosed with pertussis. The doctor wishes to start oral erythromycin for 14 days. How many 200 ml bottles of erythromycin suspension will have to give? So one bottle of erythromycin has 200 milliliters, and the strength of that, or concentration of that bottle is 500 milligram per ml. Would you dispense how much of that would you dispense to complete the antibiotic course for this patient if the child is 10 kg per dose 4 times a day for 14 days? So it's 10 milligram per kg per dose. So let's get that multiply that for the weight first. So it's 10 multiplied. So that's 10 multiplied by 10 kg because the weight of the patient is 10 kg. So that will be 100 milligrams of the dose, 100 milligram per dose. But we have to give it 100 milligram 4 times a day. So that's 4 times a day. So that means it will be 400 milligrams per day the patient will be receiving. And we have to give it for 14 days. So that will be, multiply that by 14. And that will be 5,600 milligrams for 14 days. So that's the total dose we have to give to the patient over 14 days, 5600 milligram. Now from this 5600 milligram, I can work out how many milliliters of the suspension I would give, and I calculate that from this the strength of the suspension. So the strength of the suspension says 500 milligram is present in 1 mil, and we have to give 560 milligrams. That will be present in 1 divided by 500 times 560, and that turns out to be around about 1.12 mil, which is actually very, very less, because there are like hypothetical numbers in this question. So over the 14 days, we have to give the dose of 1.12 mils to the patient, and the bottle has 200 milliliters. So 200 milliliters are in one bottle, and over 14 days we have to give to this patient 1.12 mils. So quite obvious that we will dispense one bottle, and that's the answer.